In this video, our aim will be to give an introduction to graphs in physics. The first topic we will look at is defining what a graph is. This will allow you to develop a true appreciation of why graphs are important in physics. Then, we will compare some mathematics graphs to physics graphs so you can look at the similarities as well as the differences. With this knowledge, you can determine which skills you will be able to transfer over to physics from mathematics as you plot graphs. However, before we can start plotting, it will be important to know the necessary tools which you will need to ensure you can do graph work easily. And it will also emphasize why these tools are important. Lastly, you will learn how to prepare a graph for plotting. Graphs are done to represent readings or data from an experiment, practical, or a given question. These readings are usually presented in table form since it can be organized in a neat format for further analysis. Graphs allow you to easily identify the trend of the data, which can be a lot of information in an efficient way rather than having to assume by only looking at numbers when they are in table form. Now that we understand that graphs are a representation of data, if you think about it, you would have been handling data in mathematics already. This could have been plotting things such as line graphs, bar graphs, or pie charts. All three of these graphs have something in common, and that is a title. A title allows you and anyone else looking at your graph to know what your graph is about. The next thing that we can notice is that in the first two graphs, which are the line graph and the bar graph, the axes have been labeled so that it is clear what is being plotted on which axis. From plotting these types of graphs, what you now need to recognize is that physics graphs can build on this knowledge of axes and titles and progress to applying physics concepts which you will learn throughout your studies. So what types of graphs are you going to encounter in physics? The first graph that we're going to go through is called a straight line graph. And you are familiar with straight line graphs, but in physics, it can look a bit different due to errors. When you look at this graph, you recognize that the red line is definitely not passing through all of those points, and it is not a dot to dot. It is a straight line. So a best fit line, which we're going to go into more depth in a later video, focuses on passing through or close to as many points as possible. The next graph is a curved graph. This is very topic specific, but what you're going to recognize is that if you try to draw a best fit line with your points, it is definitely not going to look like a straight line as possible. And that can give you an idea that it will be a curved graph. A curved graph is a smooth curve, which means you're not going to take your ruler and join each of those individual points, but you're going to do a freehand curve of the points that you have. And finally, we have graphs that usually combine both of them. In this graph, what you're going to recognize is that we have a best fit line portion, which is a straight line, and at the end is a best fit curve. These are the three main types of graphs in physics, and based on the topic as well as the data you have, you will eventually get comfortable with identifying and drawing these types of graphs. Important tools that you're going to need when you're plotting graphs in physics include graph paper, a sharp pencil, preferably dark enough that you can clearly see what you are plotting and where. You also need a sharpener and an eraser in the event that your pencil gets dull, breaks, or you make a mistake. Now I know some persons are accustomed to plotting graphs in pen. Then you come over to physics and automatically apply this method. However, At the beginning stages of plotting graphs in physics, it is important that you use a pencil unless you are extremely comfortable with graphs. What happens is that if you use pen from the get-go and you are not comfortable with them, what you will end up doing when you make a mistake is that it's going to lead to wasting resources and time by getting more graph paper and having to replot. Finally, you will need a 12-inch clear ruler. The clear aspect of the ruler is just a personal preference because I find it makes the process easier, especially when we get into analyzing graphs. However, the aim is simply to have a long ruler. Now let's get started with actually doing something towards getting that graph plotted. The first step is to line the axes of the graph, and that means both your y, which is your vertical axis, as well as your x, which is your horizontal axis. Once you have lined your axes, then you move on to step 2. Step 2 is determining what you have to plot. What you have to plot can be presented in various forms. This could be plot displacement against time, plot displacement versus or vs time. This simply means displacement will go on the y-axis and time on the x-axis. But one thing which you should commit to memory is the first quantity that comes is on the y-axis and the second quantity that comes is on the x-axis. So after we have lined our graphs and determined what we're going to plot, then we label the axes with the right quantity and unit. But just in case you happen to forget what a quantity and a unit is, one example of a quantity is mass, where mass has a quantity symbol of m. Quantities are used in equations. So when we get to the unit, and in this specific case, the SI unit of mass, it is kilograms. Because the thing about it is, you can also see the unit of mass as being just grams. Units come after what you have calculated, which are your numerical values. So how do we actually go about lining the axes? To demonstrate this, we will start with the y-axis first. We will need a ruler and a pencil, and we take our ruler and line it up directly at the edge of the graph paper line. Then, with our pencil, we draw vertically from the bottom to the top or top to bottom of the graph lines. For the x-axis, we place the ruler at the bottom of the graph lines and we draw horizontally across the bottom of the graph. Now I know some students tend to bring the lines away from the edge of the axes. However, I prefer to use the full size of the graph paper, only coming in when negative values are present. The final thing is to put the quantity and the unit. Therefore, when we read the example in the top left, it states, to plot a graph of force, which has a unit of newtons, against extension, which has a unit of meters. Therefore, looking at the y-axis, we get force, which is the first thing in that description, going on the y-axis with its unit of newtons. And the second thing coming in that description is extension, therefore it will go on your x-axis and you'll have extension slash m. Now we will discuss the importance of a long ruler, which you would have mentioned earlier. Right now, we have a graph and its best fit line. However, on removing the best fit line and attempting to draw it with a short ruler, what we recognize is that initially, while it may match, coming towards the end as we extend the line by removing the ruler continuously, we have now introduced errors unless you happen to have extremely good eyes and spatial recognition. You would recognize that that red line can vary from person to person. And when we compare that red line to the black line, which we originally had, you recognize that there are some errors. This is why we use a long ruler. A long ruler makes this process a whole lot easier because you are able to draw from the beginning to the end of the graph without breaking. This process could also have been done using a clear ruler. The clear ruler allows you to see if any points are behind the ruler, and as such, if you had a solid ruler, you would constantly have to pick up or move the ruler to see the points behind, and as a result, you get an easier time in plotting a best fit line. I want to thank you all for watching this introduction video on graphs. In the next video, we will look at how to determine the scale, why that scale is important, and the basics of plotting graph